In this video, let's go ahead and practice finding the derivative of 3 different trigonometric functions together. If you'd like to download a free copy of this blank PDF as well as the answer key PDF, you can find a link to that below. All right, let's get started. For number 1, we have the derivative of this sine of this 2x to the third power, right? Now, whenever we have these trig functions, I think a good thing to do is just to go ahead and see if we can make a substitution. So in this case, we're going to use u substitution. Instead of d dx, let's write d du. And instead of sine of this 2x to the third power, let's do sine of u. All right, so let's go ahead and just call this 2x to the third power. We're going to actually replace that with this u variable. So we're going to use this u substitution. So on the side here, I'm just going to go ahead and write that we have u. We're saying u is going to be representing 2x to the third power, just for a little bit, just temporarily. And so if we know u is equal to 2x to the third power, we can go ahead and use that power rule and find du, or the derivative of u. 3 comes down, 3 times 2 is 6. We're going to have 6x to the 3 minus 1 power, or to the second power here. So that's going to be the derivative of u. Now when it comes to finding the derivative of sine of u, you have to either memorize this or look it up on a chart or a kind of reference sheet that has all the derivatives of the trig functions. But the derivative of sine of u is just going to be cosine of u. So when we go ahead and take the derivative here, then it's going to be cosine of u du, or we can write cosine of u just like this, multiplied by du, or putting that du right after it. All right, so that's going to be the derivative of sine of u, right? Not too bad. What we have to do now is just make some substitutions back. Remember that this u here was really representing this 2x to the third power. So we're just going to go ahead and write this is going to be cosine of that entire expression, 2x to the third power. And then what's du? Let's go ahead and make a substitution back. This du is really this 6x squared. So we're going to go ahead and multiply this by 6x to the third power. All right, cool. So that would be our derivative. And just for good measure, to make this a little bit more clear, make sure we're taking cosine of this 2x to the third power, and then that is multiplied by the 6x to the third power afterwards. Okay. Let's check out another example together. In this one, we're going to find the derivative of cosine of the square root of 3x. So just like in the last example, let's go ahead and see if we can kind of make this a little bit more simplistic. So let's go ahead and say that instead of d dx, let's go ahead and find d du. And then we have this cosine. And instead of this square root of 3x, let's go ahead and replace that with u. Okay, we're going to make some u substitutions here. That's kind of the name of the game, just to help us out a little bit here. And so let's see, on this side, we're going to go ahead and say that we're saying that u is going to represent the square root of 3x. All right, now this is also known as the quantity of 3x raised to the 1/2 power. So that's going to be helpful as we're finding the derivative of this square root of 3x. So what is du, or the derivative of this? Well, because we can go ahead and write this using this fractional exponent, then we can go ahead and use the power rule and the chain rule here. So that 1/2 is going to come down in front. So it's going to be 1/2 multiplied by this 3x. And then we take away 1 from 1/2, that's going to be to the negative 1/2 power. But then we're also going to have to find the derivative of the inside of the parentheses, so the derivative of that 3x is just going to be 3. Now just rearranging this a bit, if we multiply this 1/2 by 3, then we can go ahead and say that this du is going to be just 3/2. Okay, and then if we go ahead and take this 3x raised to the negative 1/2 power, you can also say that's going to be the same thing as 1 over this square root of 3x. Simplifying this du even more, on top 3 times 1 is 3, and on the bottom 2 times the square root of 3x is just going to be 2 times the square root of 3x. So what is d du of this cosine of u? Well, that's the derivative of cosine of u, and you either have to memorize that or look it up, and that is going to be negative sine of u du, right? So we're going to go ahead and write this is going to be negative sine of u du. That's going to be the derivative here. All right, just like that. So that's all you have to really do there. And then we know what u is representing. U is representing this 3x to the 1/2 power. So making that substitution in, we're just going to say this is going to be negative sine of what? Well, we know what u is going to be. U, we said, was 3x to the 1/2 power. Go ahead and put that in here. He's using brackets to keep things a little bit more organized. And then what is du? Well, we found out du was going to be this 3 over 2 times the square root of 3x. So we're going to go ahead and multiply this by 3 over 2 times the square root of 3x. Now we can go ahead and write this using a radical as well. Remember, raising something to the 1/2 power is really just the square root of it. So we're going to have this negative sine of what? It's going to be sine of the square root of 3x. All right, then we're going to multiply that by 3 on top. That's going to be 3 over here. So that's what's going to be in the numerator. And then in the denominator, we're just going to have 2 times the square root of 3x. Simplifying this just a bit more, we can put that 3 in front and just say this is going to be negative 3. Just put that right in front here, multiplied by sine of this square root of 3x. And that's going to be all over 2 times the square root of 3x. So this right here is going to be the derivative of cosine of the square root of 3x. All right, cool. Let's try one last example here. For this particular problem, let's go ahead and find d dx of this tangent of this quantity of this x over x plus 1. All right, so just like in the last few examples, let's go ahead and simplify this a bit using u substitution. So instead of finding d dx, let's find d du. And then we're going to have this tangent. And instead of this long function, let's go ahead and replace that with u. All right, so basically we're just replacing this more messy looking thing with this basic u for now, right? So let's go ahead and define some things here. Let's say u is going to be this x over x plus 1, like we just said. Now what about du? Du is going to be more complicated for this problem. So we're going to have to find the derivative of this quotient over here. This is going to be x divided by x plus 1. So we're going to have to use a quotient rule, which is definitely going to be a little bit more time consuming. So let's call this top part f of x. That's really just going to be what x is. And in the denominator, we have this x plus 1. I'm going to call that g of x for now. This is just trying to be extra clear with writing the quotient rule, right? So what is the quotient rule? Let's go ahead and write this out as clear as possible here. If we're going to find the derivative of a quotient like this, it's just going to be g of x first, and that's going to be multiplied by f prime of x, or the derivative of f of x. And then you're just going to go ahead and subtract, and it's going to be f of x. So I'm going to write f of x multiplied by g prime of x, or the derivative of the g function. All right, so this is going to be the numerator. Hopefully this looks familiar from the quotient rule. This is going to be all on top of g of x squared. So we're just going to go ahead and write this as this g of x, and that's going to be squared. All right, so that's the quotient rule here. And so we're just going to go ahead and plug some stuff in here. So I'm going to go ahead and not define f and g and f prime and g prime, just because that might be a little bit long, but these derivatives aren't too bad, I hope. But so g of x is really just going to be x plus 1. So I'm going to go ahead and write x plus 1, put that in parentheses, make sure we keep those parentheses. So that's g of x. What's f prime of x? Well, we see f of x is x, but the derivative of that is just going to be 1. So I'm just going to go ahead and multiply this by 1. And then let's see, we have f of x next. Let's see, f of x we know is just x, so that's just going to be pretty straightforward. We're going to put in an x here, and we're going to multiply that by g prime of x. So we know g of x is this x plus 1, but the derivative of x plus 1 is just going to be 1. All right, so a little bit annoying, a little bit of extra work, but it was not too bad, all things considered. And so what about the denominator here? For the denominator, we have g of x squared. Now g of x is just this x plus 1. So we're going to go ahead and write, we have x plus 1, and that's going to be squared. All right, simplifying this a bit, we have just 1 times this, which just stays the same. And then we have 1 times x, which is just going to stay the same. So what does this numerator really simplify down to? It's really just going to be x plus 1 minus x all over this quantity of x plus 1 squared. All right, now this x over here minus this x are going to cancel out. So what is du? Du is really just going to be 1 over this quantity of x plus 1 squared. All right, that was quite a bit of work, but we now know that u is going to be this x over x plus 1. That was kind of from the beginning, nice and straightforward, but du proved to be a little bit more annoying, but du is this expression right over here. All right, So let's go ahead and find d du of this tangent of u. So what is the derivative of this tangent of u? Well, again, you just need to either look that up or have it memorized. And the derivative of tangent of u is going to be secant squared of u du. So let's go ahead and write that. It's going to be secant squared, and it's going to be u. Let's go ahead and put that u inside here, du. All right, so that's the derivative part, and the rest of it is just substitution, right? So let's go ahead and change this u back to this quantity of x over x plus 1. Go ahead and write that down. It's going to be secant squared. Let's go ahead and put this x over x plus 1. And then what else do we have here? Well, we have du. Du we found out was this entire expression over here. So let's go ahead and multiply that by 1 over the quantity of x plus 1 squared. And maybe you just want to reorganize this a bit. Sometimes I do this, sometimes I don't, but maybe I'll put this in front. So I'm going to put 1 over this x plus 1 squared. Some people may see it this way. And then we can just multiply that by the secant squared of this entire fraction of this x over x plus 1. All right, so this might be a more clear way of writing it, or if you wanted to stop in the previous line here, you could also maybe just put brackets in here just to make it super clear to people that this 1 over the quantity of x plus 1 squared is just not a part of that secant squared function, right? So either one is probably fine. All right, so there you have 3 different examples of finding the derivative of some trig functions using some u substitution. If you needed to brush up on using the quotient rule or the power rule or the chain rule, that was used a little bit in each of these examples, just to help with finding the derivative of each of the u substitution parts. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.